secondary xylem, right at this transition. So cork, cortex, and that makes this the cork cambium. All right. And more repetition. I like that one. It's a nice sharp photo. You guys ready? Up close and personal. Now that one's labeled tracheids. I'm not going to make you responsible for the xylem cells. I wouldn't pull the multi-tiered thing into gymnosperm. It only has tracheids thing on you, but I'm going to do that to you. So that I know some of you are looking at it going, why is it labeled tracheids? It's not. It really isn't.
What about the rays?
The rays are the same. Those are xylem rays. You have most of the xylem goes up and down, and you have a little bit that goes lateral.
Are you going to ask about them?
Oh yeah, absolutely. You can see them. They're a little fuzzier in gymnosperms for whatever reason. Kosher? Some people are still snapping photos. No worries. It's cool, Crystal. It doesn't matter. Come on. All right. And now you have a very specialized reason why you're looking at this. Why are you looking at this? Which is lenticel. Is that a soup? Where's my bread?
No.
No?
What is it called?
A lenticel. So this is, you had one very specialized slide. 56. 56, this is, there's only one reason. There's only one reason why you look at this. What's going on here? Gas exchange. These cells are living. The cambial cells are living. The cortex is living. The phloem is living. The secondary phloem is living. So they need a little gas exchange going on. You guys with me? And it's also, what was that, 56? Okay. Now here you have a stem specialization.
Yes.
What's going on here?
Hydrophyte.
Hydrophyte.
Yeah.
So remember the big spaces you saw in the leaves? You have the same big spaces in the stem. Why?
Air spacing.
So you can float. Exactly right.
Loves water.
It's the hydrophytic stem. You can see the air chambers. You can see the parenchyma, air chambers, parenchyma, epidermis. Kosher? What's going on here? Parasitic stem. And notice what's going on. Not that this is a testable idea. This is a dicot. You can kind of see the ring. And what you have is the parasite using the hostorium to invade the vascular tissue. Now, it's mainly there for food, but the fact that it can steal a little bit of water is just kind of a bonus plan. So this is the parasite, this is the host, this is the hostorium. Do you have your picture labeled?
Yes.
On 57. Okay, so here's the host, here's the parasite, here's the hostorium. And so the basic scheme is the parasite is using its vascular tissue to invade the host's vascular tissue. Think about mistletoe. In the middle of the winter, it's green, the tree's dead. That's why. Now here you have a little bit of stem stuff. I was hoping there was a picture here I couldn't remember. Get out of the way. Okay. Now what do you got going on at the top? What's up here, y'all?
Terminal bud.
Terminal bud. What are these? And this?
Nodes?
Actually, yeah, nodes. That's another term that would be applicable. Because the leaf was attached here, so this would be a node. This would be the internode. These are the axillary buds that are starting to grow. The leaves fell off. You got the little buds in the axils. Now you're getting next year's leaves starting. Can you see the leaf scar? Another beautiful thing about this picture. Can you see the previous year's terminal bud scar? Right. So you got a stick in your hand. Let me remind you of that. Don't be surprised if you wander around to a station and there's a stick and ask you how old it is. Count the rings, add 1, you're done. Right? So if there are 2 sets of terminal bud scars, you see 1 year, 2 year, the 3rd year of progress. You see 4 terminal bud scars, 5 years. Right? So terminal bud scars plus 1, and that's the age of that particular stick. There's those annular ring-like terminal bud scars. Now there's one other thing on here that's very subtle, but you can see it.
Oh, the little tiny,
See the little pinholes. You can see the lenticel. There's one right there. Does it just say, I'm a pinhole? Now this will be very obvious. If I was to put on a stick, if I was to put a lenticel, there'd be a big pin in here going, what is this about? Okay? Don't let me interrupt your feng shui on that. If there's a pin in a hole, or you may be going, well, didn't the pin create the hole? Maybe. Okay, you with me? Now we're having fun, aren't we? Why is this stuff dark in the middle?
why is it dark in the middle?
Yeah. Versus this. Is this, what is all of this?
Wood.
Wood. So why is this wood darker than this wood?
Summer wood. Spring.
Too far away. Yeah, that's a good question. So some of you may be going, okay, is it a seasonal thing? Remember, your actual rings that are a little bit hazy because you're far away are your seasons. Here's a season, here's a season, here's a season. So this tree is probably somewhere in the neighborhood of, I don't know, 30, 40 years old. This xylem is all plugged up. So this is heartwood. This is non-functional. And this is sapwood. This is functional. So when you have that whole tree cylinder, you have 2 possibilities of the way the xylem will look. Over time, other secondary compounds that are in the water, tannics and all those other things, will eventually, oils, some trees they produce an oil, will eventually plug up. So this is heartwood, and this is sapwood. What's all this business on the edge?
Bark.
The bark. Now just to kind of go back, what all is out here? All your lateral meristems, your vascular cambium, your cork cambium, and the secondary phloem, and the cork and the cortex. So when you're looking at it at this level, you can see wood and all the rest of it.
So the dark wood is the heartwood,
Dark wood is the heartwood,
and the sapwood.
and then the lighter is the sapwood. And let's see, I think the next one is a little bit closer. Now here, you're at a level where you can actually see the seasons. Okay, so you go, it's a little fuzzy, let me get out towards the edge where it looks a little cleaner. Spring, summer, winter. Spring, summer, winter. And then you're right here at the edge, so this is the edge and the secondary xylem, and then all the rest of that stuff that we can see microscopically is out here.